Parallel lines are the only type of line that will never intersect. All other types of lines will intersect at some point or another. And normally, in the past, in order to tell if lines are parallel or not, we've either just looked at them and kind of tried to guess whether they're parallel or not, or in geometry we learned that if they had the same angle, then they were parallel. But suppose we didn't have a graph and we didn't know the angles. But let me draw a graph first anyways, just to help along. So we have a set of parallel lines. And if I were to ask you, what makes these lines parallel? If I was to ask you for what piece of math is making these lines parallel? What mathematical construct do we know about is making these lines parallel? Well, in a couple of sections previous, we just learned about slope. Slope is the rate of change of the line. Parallel lines have the same rate of change. So that means if two lines have the same rate of change and they're not on top of each other, they'll never intersect. So that means that if we have lines with the same slope, then we have parallel lines. The only difference between these lines is just the y-intercept. So say we had our form y is equal to mx plus b. The only difference between this line and this line is the b. The m, the slope, is going to be the same. So let's look at an example. Suppose we had two lines. Our first line is equal to 2x plus 3y is equal to 6, and line 2 is equal to 4x plus 6y is equal to 0. And I want to know if these lines are parallel or not. So like we were just discussing, parallel lines have the same rate of change. So that means if they have the same slope, they're parallel. So let's find out if they have the same slope or not. So I'll do the first line. It's 2x plus 3y is equal to 6. Subtract 2x, 3y is equal to negative 2x plus 6. Divide by 3, y is equal to minus 2/3 x plus 2. And for our second line, we have 4x plus 6y is equal to 0. Subtract 4x, 6y is equal to minus 4x. Divide both sides by 6, y is equal to minus 2/3 x. So here we notice we have the same slope. We just have different y-intercepts. The y-intercept of this line is 2. The y-intercept of this line is 0. So let's graph these lines and see if they're parallel. So I'll do a different color. I'll try to make this as accurate as possible so they come out more or less parallel. Alright, so our first line has a y-intercept of 2 right here, and we can find the x-intercept for this for this line by putting y as 0, so minus 2/3 plus 2. So subtract 2 is equal to minus 2 over 3. This is x. Multiply both sides by 3. I get minus 6 is equal to minus 2x divided by 2, x is equal to 3. So the x-intercept is 3 over here. And let me use the line tool to try to make as straight a line as possible. Yeah, it's straight enough. Now for our second point, our y-intercept is 0, and our x-intercept is also 0, so I have to do a different point. Let me pick x is equal to 3. So say x is equal to 3. So I put in 3 for x, so y is equal to minus 2 times, or minus 2/3 times 3. So y is equal to minus 2. So when x is 3, y is minus 2. So it's right there. Let me get my line tool out. Well, it's a little bit crooked, but you can more or less see that these lines would be parallel. And let's suppose now that we wanted to find another line. Let's suppose I ask you, I want another line that's parallel to both of these lines. How would we go about doing that? So I want a line. I'm going to ask you, give me a line that is parallel to y is equal to minus 2/3 x plus 2. I want another line that is parallel to this. How do I do that? Again, all we have to do is use our slope. So there's an infinite number of lines that are parallel to this. I mean, we can pick any line. All we have to do is just change the y-intercept. So y is equal to minus 2/3 x plus any number, any constant. It could be 1, we already have 2, but it could be 3, 4, 5, 5.5, etc., etc. And all we're doing, so the y is equal to 3, that would be like here somewhere. And the one that's equal to 5, that would, oops, oh well. And the one that's equal to 5, that would be here somewhere. So all we're doing is just changing the intercept, but all of these lines are parallel. So again, just to review, parallel lines all have the same slope, and the only difference is their y-intercept.